Thank you for being here today for this really interesting discussion panel that we have organized with members and representatives from large astronomy consortia, from large astronomy organizations. Particularly thank you to all the panelists who are very kindly sitting their time. In some cases, it's the middle of the night for them. So we ask that you all are respectful. Obviously, if you want to ask any questions, they're very welcome. But please consider that everybody is just giving their time to be able to address them. So be polite. I will allow introductions from everyone in a minute, just to give you a quick idea of how the panel will run. We'll have introductions first. Then we will pose some questions that we gathered from all of the A4E community. And we will have time for live questions as well, which Sarah and I will moderate. And hopefully we will be able to cover all of the key points in this discussion. So Sarah and I will be essentially asking the questions and moderating them, and we will allow the panelists to answer them. So without further ado, we have a lot to get through today. So we'll go to introductions. So if you want to get started, maybe Elena, you can start.
Yes, hello. So let me share my screen. There we go. First of all, thank you very much for having me here. I'm Elena Llopis from ESO, the European Southern Observatory. This will be very fast because probably all of you know this. So ESO is an intergovernmental treaty organization. We have 16 European member states and one strategic partner, which is Australia. And our facilities are located in Chile. Our mission is to build and operate world-class ground-based astronomical facilities and to foster collaboration in astronomy. This is where our facilities are located, but going to sustainability. So ESO has made sustainability one of our core values. So these are the assumptions that underpin our activities. And concretely, we have set and determined that ESO fosters diversity and inclusion, and that ESO believes in the key role of sustainability for its future. We see sustainability in the main three pillars, so social sustainability, economical sustainability, and environmental sustainability. I am the head of the Quality and Sustainability Office. This was created in May this year, and it's in the directorate, so in the Office of the Director General. And it provides services in quality management, sustainability and diversity, and risk management. We have also are recruiting right now the quality process manager and the sustainability and diversity officer, who will start in February. I wanted to point out that we have gone through the UN Sustainable Development Goals, and we believe our main impact are in those I show there, but I don't want to make it too long. So here are the links to the different pages. You can find more information on it and my contact. And I'm happy to the discussion. Thank you.
Thank you, Elena. That's sounding fantastic. I'm really glad to see that ESO is making these steps forward and having a dedicated position for this as well. Violette, do you want to go next?
Yes, let me share my slides. All right, I'm going to introduce the Event Horizon Telescope Consortium, of which I'm a member. I am actually at Leiden Observatory myself. I'll tell you a little bit more about why that's slightly different. The Event Horizon Telescope is a collaboration of more than 300 scientists in 19 countries. It's a very complex project and has a great internal structure, but it's not per se an actual observatory that's uniformly funded. It's made up of many individual observatories that actually work together as a collaboration. The main targets are M87 and Sagittarius Star, but the point here of the discussion is that the array is not homogeneous. We have different issues because of different diameters, different sizes. Telescopes are at different needs, different requirements. So it's a kind of a challenging thing to make it, to find one common goal for all of them. The way the collaboration works is that we meet twice per year. Once is in person and once is a virtual meeting now. This is a picture from our last meeting from the summer, actually the first since the pandemic. This is me in the corner here. We observe also once per year in April, and observers do travel to all the sites, and the data is then also shipped. Of course, this is a data analysis intensity. We're going to be talking about computing later in the discussion. The way the telescope works, I think all of you already know, but just to give a nice visual, is that all these various inhomogeneous telescopes ultimately observe together over time. And as they integrate over a target, they build up this really nice UV coverage, and that allows to make a very nice image. Now, of course, that goes without saying that one of the goals of the EHD is to have more antennas to make an even nicer UV coverage. And so these are the ones already observed, and these are telescopes that are going to be added over time. So let's talk about sustainability. We do not have an actual sustainability planning committee. We're obviously probably the opposite extreme from our previous speakers, ESO. It's a very young in collaboration. It's very dynamic. It's growing, and it doesn't have one body that actually governs it and funds it. It depends on many different funding, and each telescope has to decide whether they would want to get into sustainability goals or not. Of course, ALMA is going that way already, which is it makes me really happy personally as well. We fought for this for many years, and ESO plays a big role in that. But all the individual telescopes make their own decisions at the end of the day. So this is one of the challenges also that we need to discuss. How can we make such collaborations, go towards the same goals in terms of sustainability? And also, I'd like to mention that there are cultural differences when it comes to these issues, and I don't know what is the best way to address them. As a collaboration, we did learn from COVID times. So one of the two collaboration meetings is now online, which makes it also more inclusive, and people are very happy about that, and I think it's very convenient. And also, there is very serious planning going towards remote observing for all the sites. And if I can leave on a good note, I think we did invite Adrian Poole for our next online meeting, which is going to be collaboration meeting, which is going to be in December, to talk about A4E. So there is certainly a lot of interest towards this from the whole collaboration. And I'll leave it here. Stop sharing.
Thank you, Violette. The EHC collaboration has really been in the news and kind of in the public eye. So I'm really glad that you're here and that these issues are being discussed. It also shows some of the challenges we are facing as a community, being so heterogeneous, both in the ways we work and where we are. Elisabetta, do you want to go next?
Sure. Can you hear me well?
Yep, all good.
Do you see my screen?
Not yet. Can you try again? Now it's coming through.
Yeah.
Thank you.
So this is me. Nice to meet you all, and thank you for this invite. I'm glad to be here. My name is Elisabetta Lamboglia. I work for the European Space Agency. As a background, I'm an astronautic engineer. I graduated in Italy. This is not to talk really only about myself. These slides, it's really to say we are going through, let's say, a paradigm shift at the European Space Agency. We're really starting a new era where sustainability and climate is really one of the key principles and key actors. And this is because it's the moment to act. I've been covering the role of climate and sustainability before coordinator, and now it's becoming more on the leadership side for what will come next for the Director General Strategy Office, directly under the Chief Climate and Sustainability Officer, who is my boss, direct boss. This is to say that what will come, let's say, very soon, it's not let's say, coming out of the blue, but there is a long history behind that. Let's say that ESA is acting towards corporate and social responsibility and acting as a role model for the entire, let's say, space community, at least for Europe, and also with a lot of interaction with international partners. And we are reporting since the year 2009, every 2 years, so with biannual reporting on sustainable development and how we're going to contribute to sustainable development. And let's say, covering a lot of aspects, starting from governance, going through organizational, and covering several topics, not only scientific ones, but looking also forward in terms of corporate and social responsibility. Now, what I would like to stress associated to this invitation today in terms of sustainability, let's say, we are not only compliant with the international standard, with the ISO in terms of corporate and social responsibility, but we have very, let's say, specific matrix that covers also the mission objectives in terms of scientific missions, space missions, and how we cover and try to cover as much as possible a wide range of sustainable development goals as defined by the international framework of the United Nations. So as one of my colleagues today, the other speakers already mentioned, it's a multidimensional problem. We have environmental issues, we have social and economic issues, and then all of them are not totally disconnected. So this is a quite challenging objective to try to address all of them and try to maximize with this what is the contribution of space in that regard. So this is just to introduce a little bit what we are doing. I'm sure that during this panel discussion, we are going to have the opportunity to maybe deepen a little bit some of the topics I'm just maybe introducing now, and just looking forward for the exchanges that will come. Thank you very much.
Thank you, Elisabetta. Again, ESA is very much in the public eye and in the political discussions. So I know it's and very closely linked to industry as well, more perhaps than a lot of these other organizations. So I'm really glad that you can be here discussing these issues. It's very important to have these conversations. Thank you for being here.
Thank you very much.
Thank you. Patrick, do you want to go next?
Okay, let's see if I can share my screen. Okay, good morning, good afternoon, good day, wherever you are. My name is Pat Seitzer. I'm with the University of Michigan, and I'm here on behalf of COSPAR, the Committee on Space Research, and in particularly its panel on potentially detrimental activities in space. Now, COSPAR doesn't operate any telescopes, but it does run meetings every 2 years. And our primary interest now is on the long-term sustainability of space. And that's a phrase you're going to hear repeatedly, hopefully today, but throughout the next couple of years, the long-term sustainability of space. Our concern, or my immediate concern, is how the space environment is changing and how it affects ground-based astronomy. This was a string of over 50 satellites that were launched in May of 2019, over 3 years ago by SpaceX. And this caused astronomers to panic because they thought, is this the future of the night sky? There's over 100,000, now over 400,000 satellites being planned for launch into low Earth orbit. And the effect on the space environment is can be quite severe. Conjunctions, collisions, you name it. So this shows you what the effect on ground-based astronomy will be. This is a particularly lucky image that was taken in November of 2019, and it shows 19 Starlinks crossing the field of view. This is the effect it has on space, on both ground-based and space-based images. So a couple of things have come out of this. You know, what can the astronomers do to convince the operators and the owner-operators and launchers of satellites to make them as faint as possible? Clearly, the best thing for the long-term sustainability of space is not to launch anything new, but that train has left the station. A couple of things have happened now. And some of them came out of COVID, not out of any deliberate policy by the astronomical community, but the COVID pandemic induced people to do remote observing. And so myself, I've observed twice on large telescopes, 3 times now on large telescopes in Chile by sitting in my office in Ann Arbor, Michigan. I estimate that Michigan astronomers themselves have not made at least 30 trips to Chile over the last 2.5 years, just because of the availability of remote observing. And that's a substantial impact on the environment. Finally, COSPAR itself is now running totally hybrid meetings, such that you can either go and attend, which has many advantages, but you can also listen to all of the sessions remotely from your home, no matter what the time zone is. And with that, I will send it back to you.
Thank you very much, Pat. This is a topic that all of us professional astronomers are certainly very concerned about, but I'm not sure how much of this concern is actually reaching the broader public. So it's very important to highlight this. Thank you so much. There's also a recent long report by Andy Lawrence on the topic, which I'm sure you're familiar with, just highlighting it for anybody who doesn't know about it. Brian, do you want to go next?
Very good. Hopefully that can be seen. Okay, good. Good day. My name is Brian Miller. I'm an astronomer with NORLAB and Gemini Observatory. I'm based in La Serena, Chile. And I'm very happy to represent NORLAB's environmental sustainability program. NORLAB is a relatively new organization. We are sort of a collection of the NSF-funded nighttime OIR facilities, which includes the Community Science and Data Center in Tucson, the mid-scale observatories at Cerro Tololo and Cape Peak, the International Gemini Observatory, the Vera C. Rubin Observatory once it enters operations, and the US ELTP program. And the Environmental Sustainability Program aims to reduce the organization's carbon footprint by about 30%, or about 2,500 tons of CO2 equivalent in the next 5 years. This diagram here shows our current carbon footprint in 2019, showing the major pieces of operations, travel, both summit and base, energy use at the different sites. And we're going to achieve this reduction first by reducing our NORLAB funded travel by about 50%, which is this red hatched area there, and then use the savings from that to invest in energy efficient equipment and renewable energy production at all the sites, which will result in savings in the other hatched areas. Just let you know that this diagram does not include future Rubin operations. So we're going to obtain this other reductions by installing higher efficiency transformers, changing single pane to double pane windows, especially in the older buildings, changing to LED lighting, updating the data centers to have hot and cold zones and other efficiency improvements, and then installing lots of PV, including 220 kilowatts at the base facility in Tucson, an additional 100 kilowatts at the base facility in Hawaii, and a total of 800 kilowatts divided between the summits and base in Chile. In addition to all of that, the NSF has now provided us with funds to work towards generating all of Gemini South's mountain electricity needs with PV, which is an additional 810 kilowatt system. So that'll be added to the current PV system that we have on Cerro Pachon, and see in that picture there. And then we have lots of future projects. We'd like to do battery storage, more PV, EV chargers, transformers, continue window replacement that we will do as funding becomes available. So please, there's an e-poster that summarizes some of this, and please see the upcoming talk by Nicolas Flagey. Thank you.
Thank you very much, Brian. These are some of the key optical telescopes in the world. So it's so good to see that you're taking this multi-pronged approach to reducing carbon footprint and making things more sustainable, and taking the lead in a way in how these things are operated. Gert, do you want to go next?
Yes, thank you very much. Let me share my screen. Yes. You can see it?
Yeah, all good.
Okay, thank you very much. Thank you for having me here on this panel. It's an honor to be here. My name is Gert Kruithof. I work at Astron in the Netherlands. We operate the International LOFAR telescope on behalf of all the European partners. You see the telescope on the lower left with the 52 stations spread over Europe with tens of thousands of dipoles. You see a picture of what we call the core on the upper left corner with 6 LOFAR stations, let's say on an island, and next to it, the Irish LOFAR station, one of the international stations. We have a central compute in the Netherlands, the orange dot on the map below, and 3 storage facilities for a long-term archive in the Netherlands, Germany, and Poland. Some time ago, we asked ourselves the question, okay, and now what is the footprint of LOFAR, both in terms of energy and environment? And environment, we first reduced to the carbon footprint. It's broader, of course, and we will look into that later. So what we did is we made a model of LOFAR in terms of all of its components, but all of its processes as well, including, for instance, on the top left, you see manufacturing of the equipment that we have on the ground, the embodied footprint of all the stuff that we have there, the site preparation of all the sites that we have. But we also include the development of the facility, so not only the operations, but also the development. And
sorry to interrupt you, Gert. I think that the slides are not changing. I don't know if you press forward or...
No, not yet. I'm
okay.
ready, almost ready to do so. Thank you.
Thank you, sorry.
Yeah.
Thank you.
Yeah. But also the buildings that we have at Astron and our partners in the commuting of personnel. So we try to cover it all and just see where we end up. This results in a white paper which will be published in December. It's almost ready, but currently under review. So if you want a copy of this white paper, drop me a note. My mail is on the low right corner. I'm happy to send you one whenever it's public. A bit of a sneak preview of how this works for us is on the top, you see the LOFAR telescope with all the components, do a life cycle analysis on all those components, with the bills of materials, the construction data, the contracts, etc. And then we use conversion factors, either benchmark data or supply chain data.
Sorry, I think your slides are still not changing. So what we can
okay,
see
then,
is the...
let me see.
There we go. Thank you so much. Sorry.
Okay. No, that's fine. Thank you for reminding me. So you see the LOFAR, you see the picture of the LOFAR telescope, the components, and how we did the analysis in terms of getting the data and converting that to carbon and electricity. And on the lower left, you see the organizational aspects in terms of our buildings, installations, and benchmark. So you see some graphs on the right-hand side. They are not ready yet. They are currently under review. But it gives us an idea of where we have the largest impact in terms of energy consumption and also carbon footprint. Now then, you can ask the question, okay, and if you take a typical LOFAR observation, which is, let's say a typical one is 8 hours on sky imaging using, in this case, the LOFAR Dutch array, not all the international stations. And let's just assume that for this publication, all the work that's done from the authors is 1 person year. We use average numbers that we just saw for commuting, electricity, and heating. And let's just assume that this publication is presented to a conference somewhere in Europe, and we travel there by airplane. Then you see on the right-hand side in the table what is the carbon emission in this case, what the contributions are. It's roughly 6 tons for this observation. And if you then look to the future, the years ahead, we have plans to make the buildings climate neutral so that the heating of the building goes to 0. Of course, then the building electricity goes up because you have to replace the building heating with electricity. We assume that the commuting, which is substantial, will be reduced because our employees are motivated to go to green transportation. The science processing is relatively low in this table. And you have to travel to the conference, which of course in 8 years' time you won't do because you will be in an online conference, and then you'll be able to reduce the footprint by roughly a factor of by 50%. Now these data are just a first draft. There is a lot of error bars in these numbers, but it gives us a clue on where we can manage and where we can to look into ways to improve. And I'll be happy to share those thoughts with you in this session and get inspired by you. So thank you very much.
Thank you, Gert. As part of LOFAR myself, I can say I'm not biased at all in being very happy that this is all happening and that you are again approaching these from multiple angles. While we're on topic, Elisabetta asked when you expect that this paper will be published.
Yeah, I would be really amazed, I think, by your results, and actually I'm very interested to read it. So whenever it will be, if you could distribute it, then I would be glad to read it.
Sure.
Thank you.
Thank you. John, do you want to go ahead?
Sure. Let me find the right window. Sorry, if anything goes wrong, I'm going to blame the late hour here in advance. Can everyone see that? Not on the first slide. I'll just back it. Okay, so I'm John Reynolds. I work for a multi-discipline science agency in Australia called CSIRO, Commonwealth Scientific and Industrial Research Organisation. So, but I'm kind of wearing two hats here because I'm representing CSIRO, the larger organisation, but more specifically the radio astronomy part of CSIRO, which is called the Australia Telescope National Facility, which I've got a slide on in a second. I should also say thanks for inviting me to join this discussion. I'm on a bit of a learning journey in this sphere. I don't pretend to have any official credentials in sustainability as such. I'm just an interested scientist at this point, but I have pulled together some of the resources to explain where we're at and what we're doing. So just a very quick overview of what CSIRO is. You don't have to read it all. I guess the headline items there, we've got about 5,500 staff across Australia, about $1 billion and a bit Australian dollar budget, 55 sites, very diverse portfolio of research activities, including what we call digital national facilities and collections. That part is relevant because that's where radio astronomy sits. Sorry, I'll just jump around a bit here. This locates the radio astronomy part of CSIRO. We're in the group that I mentioned, National Facilities and Collections. So that itself is a fairly diverse set of research portfolios. We've got astronomy, marine research, national collections of insects, amongst other things, and plants. Australian Animal Health Laboratory, which has just been renamed, the slide's out of date, where we do biosecure research and information technology research. So just to put you in the picture with CSIRO as a global or as a whole and its ambitions for sustainable growth, we have a 10-year sustainability plan, of which this is the most recent report, the 2022 report. So this includes the 17 sustainable development goals that I think Elisabetta mentioned that are all included in this 10-year plan. I guess the headline as far as CO2 emission is concerned is that we have a non-zero emission target of 0 by 2030. That's scope 1 and scope 2. If you include scope 3, it pushes out to 2050, but it's certainly been taken very seriously in CSIRO, and for good reason, because we're currently emitting about 90 kilotons per year of CO2 equivalent. So the radio astronomy bit of CSIRO is what I mentioned, the Australia Telescope National Facility. So some of these radio facilities you may have heard of. You may have heard of Parkes in New South Wales, where near where I'm located or broadcasting from at this minute. We have another telescope further north called the AT Compact Array, so Telescope Compact Array, which is an interferometer. And our newest telescope is in the west, in a remote area of Western Australia called ASCAP, which is a precursor telescope to the much larger SKA, Square Kilometre Array, which is coming. We also make heavy use of a supercomputer at the Pawsey Centre in Perth, which you can see down the bottom left-hand side there. We also manage NASA's Deep Space Tracking Station at Toowoomba and ESA's Deep Space Tracking Station at New Norcia. So I mentioned SKA. So Australia is one of the 2 sites for the SKA. We're hosting SKA Low, roughly where that MRO, Murchison Radio Observatory arrow points to. So this is one of the best places in the world to have a radio telescope in terms of freedom from man-made terrestrial radio interference. But we're certainly not immune from satellite or airborne RFI, radio frequency interference. So I was very interested to hear Patrick's comments on SpaceX and Starlink, because this affects radio astronomy as well as optical astronomy. So very interested to hear that connection. All our observatories are currently remotely operated. We switched to remote observing in 2012, I think, which has obviously saved a lot of travel. But there is an interesting publication which folks may be aware of, which came out in Nature Astronomy in a set of sustainability papers in 2020. There was a particular paper by Adam Stevens et al., which looked at the impact, the carbon footprint of Australian astronomy, and came up with a slightly surprising and scary figure of 25 kilotons per year can be attributed to Australian astronomers, just Australian astronomers, on doing their day-to-day work. And the biggest piece of that 25 kilotons was our use of supercomputers, which we're addressing. The next biggest chunk was air travel, which has substantially reduced due to COVID, as you can all imagine, dramatically decreased in the last 2 years, but has started to rebound a little. But I think the challenge in that area is to lock in the gains that have been made. And part of that is moving to more remote meetings and a smaller physical footprint of our sites. So that has actually decreased to reflect the fact that many folks are working from home. So that, in a nutshell, was my introduction. Thank you.
Thank you very much, John. And thank you for bringing the point that, we have massive geographical challenges to face. This is particularly true of Australia, but it shows also how energy consumption, the carbon footprint of that consumption, really varies hugely geographically. We will have a question on these later. Kevin, do you want to go ahead?
Yes, sure. Greetings all. Morning, afternoon, wherever you are. I guess here in Hawaii, the universal greeting works across time zones is aloha. Thank you, Sarah and Beatrice and the rest of the A4E organizing committee behind the scenes on putting together this symposium and this event, and for inviting me to participate in this important panel discussion. Just for context, I'm here representing the WM Keck Observatory, which operates the twin 10-meter telescopes on Mauna Kea on the island of Hawaii. The Keck Observatory is owned and operated by a partnership between University of California and Caltech, and there's a 15% operational stake from NASA. Telescope time is mostly split between astronomers from Caltech and University of California, sometimes also allocated to University of Hawaii astronomers. Astronomers worldwide can apply for NASA time, and we also have arrangement with other institutions, such as our friends in Australia from Swinburne, and also Yale on the East Coast for their astronomers to use Keck telescope time. I myself, I'm not an astronomer, I'm an engineer, so thank you for including me in this. I've been with Keck since 2005, and for most of that time as a senior engineering manager up until a year ago. And that's when I took on a new position as sustainability advisor to the director. And I realize, as Elena mentioned earlier, sustainability has many dimensions. In fact, the UN 2015, they articulated 17 sustainability development goals for 2030. Lucky number 13 is climate action. Over the last 12 months, I've been leading an effort to ask and seek answers to the following 3 questions around climate action. How green is Keck now? How green do we aspire to be? By when? And what is it going to take to get us there? I expect we'll have opportunity over the next hour or so to dig into some of those questions. To the extent we don't, and I don't have any slides to share with you right now, but you can get some additional background on this and a lot of details if you check out this month's Nature Astronomy. That's November. It's got a comment piece on a path to net zero carbon emissions at the Keck Observatory. And you can just Google Keck Observatory carbon footprint and it'll get you right to it. So while I'm not representing or speaking for the other Mauna Kea observatories, I will add that we are on the same island. We have people, goods and services arriving via air or boat or internet to the same island. We all have vehicles that climb the same mountain every day, and we all are connected to the same electricity utility grid. So while the numbers and scales will differ, there's definitely some similarity and challenges and opportunities which we can all share and learn from. Finally, if we have, I guess we have a minute, I just want to share a personal story. I don't think anybody on this panel needs a wake-up call, but just the reality of climate change, we experienced a dramatic and disturbing one here in Hawaii in 2015. I've been outrigger canoe paddling 3 mornings a week before work, right around this time, year round for the last 15 years. And we paddle over the same 4-mile stretch of coral reef each time. And over the course of just 3 months in the summer of 2015, we witnessed a very colorful and seeing a very, very colorful and vibrant coral reef. It went through a coral bleaching event, and within a matter of weeks, it turned from vibrant color to a lifeless grayish olive brown. And that was 7 years ago. It affected tens of miles up and down the coast. And there's been some selected recovery and adaptation, but nowhere near to the level it was before. And with both ocean temperature rising and acidification, who knows how long that's going to take for a full recovery. So, yes, indeed, climate change is real, it's happening, and that was just a visual recognition of that for myself. Not that anyone else here needs convincing. So I hate to end on a sour note like that, but I just say I am really bullish about the opportunity that's here, especially on the Big Island of Hawaii. Right now, the same week, there's a conference being held that some of our colleagues are attending on what's happening in the county of Hawaii and this island, and it's been sponsored by the mayor, who's the lead executive for the government on this island. So with that, I'll turn it back to you, Sarah.
Thank you, Kevin, and thank you for bringing these important points, both that, as a community, we're not just astronomers, there's a whole bunch of other people who are also making astronomy happen with different backgrounds, and this is something that actually strengthens that. The diversity of our communities is really important. And also, again, some of the challenges, particularly in places like Hawaii, that we are facing. I just posted the link to the paper you mentioned in the chat so people can see it. So we'll take we'll ask some questions now. As I said, we put together a list of questions by polling A4E members and putting this list together between all of us. But we're keeping track of the ones you're asking in the chat as well, and we will try to address those live. So some of them partially overlap, some of them don't. So just to get things started, I would ask you, what would you say is one crucial challenge that your organization is facing in its efforts to become more sustainable, and how could this challenge be faced? As in, just pick one key thing that you're concerned about. Kevin, when you're unmuted, do you want to go first?
Sorry, was that with me?
Yeah, so what would you
Sure,
say is one
sure.
crucial challenge that your organization is facing in its efforts to become more sustainable, and how could this be faced?
Well, the first challenge is really understanding the extent of the problem and that we're trying to address, and doing a full greenhouse gas inventory. Estimating the direct emissions was fairly straightforward but tedious. The indirect emissions associated with electricity, that was easy, except for one key factor unique to this island. But the real challenge ahead is estimating the carbon footprint from all the indirect sources that we neither own or control, but result from consequences from our activities. So far, we've really only looked at the air travel component of business travel. And that is, we suspected that would be big, and indeed it is. It's number 2. So really, how far do you go, and how complete and accurate do you go, and how much effort do you allocate to understanding all those indirect emissions? That's really one of the challenges we're facing. And how do we, how might we approach that? Well, certainly learn from what others are doing. So I'll be looking to see how others are approaching it. Are there any, pragmatic ways? I mean, I imagine some iterative process that tries to identify the big boulders and big opportunities where you might have big impact. So that's the big challenge that we have ahead. We have a fairly good strategy for scope 1 and 2. It's really the scope 3.
Thank you. Any other takers on this question?
I would go. So I fully agree with Kevin about the challenge on seeing the current situation, but and I also agree on the next step. So for me, I believe we do have a common understanding of sustainability and awareness, but the big challenge is to change the working structures we have been working with as normal for all time. So we are dependent on all our partners, on their sustainability concepts. If they have sustainability initiatives and so on, so we are bound to structures which we cannot influence, I would say, and this is the challenge. How do we we need to find a way to collaborate in the same direction. Thank you.
Thank you, Elena. Gert, do you want to go next?
Yes, thank you very much. One of the challenges, I think, is if you look at the carbon footprint that is embodied in our facilities, then being sustainable would imply for me that we make as much use as possible from whatever we have on the ground. And that conflicts to some extent with searching for new boundaries in science, where you sometimes want to build something new. And there is a conflict between maximizing the science of an existing instrument and building something which is groundbreaking new. And that's a difficult discussion, I think.
Thank you, Gert. That's a very important point, and one that we are also trying to tackle within A4E. Brian, do you want to go next?
Okay. One challenge for us is coming up with the money to pay for especially new initiatives. I mean, these are multi-million-dollar efforts. Our next 5-year program that I mentioned is going to cost about $5 million. Fortunately, the NSF has been very supportive of us. The extra 810 kilowatts for Pachon is about $2 million. And we'll be applying for additional multi-million-dollar funding supplements for the rest of the projects.
Thank you. That's another very, very important point. If we can move on to the next question, just trying to cover a lot of ground, obviously, in a very short time. In which aspect of sustainability do you think your organization has made the most progress so far? Any takers for this one?
Well, if you want, I can start first. I actually have a couple of slides, maybe a nice supporting material. Just tell me if it's working.
Yeah, that's good.
Yeah, just a very quick answer to your previous question. The real challenge, at least from the European Space Agency one, is to try to respond to these two main lines, because we want to be sustainable on one side through ESA programs and space missions and activities, supporting cross-cutting activities. On the other side, we need to reduce our, let's say, our own emissions. And I'm talking about scope 1, scope 2, and that part of scope 3 that goes under cross-cutting activities, let's say corporate. So we have a number there, which is calculated, say, science-based. And I mean, the way we want to do that is through, let's say, an entire agenda and program. So there are many, many activities. They are not totally disconnected. Actually, they're very much connected. There are bridges between one activity, one pillar, one package, and the other one. But then what is really important is to stress that only in the past 1 year, it has been a very, very intensive year. From the end of 2021 to the end of 2022. So nowadays we've been working on the strategy to make this happen. And then the real, this preparatory activity, but the real ESA Green Agenda, what we call ESA Green Agenda, will come really starting from now onwards. And everybody knows that the Ministerial Council just has been completed the past week. So we have our, let's say, budget, and we can move through these different scenarios. So what is important to say is that there's a lot to do. And on one side, it's very complicated because it's important to have proper expertise and all the manpower and resources. On the other side, the difficulties is to work with core activities. It means space project. It means life cycle assessment, eco-design, technologies. On the other side, working also on our emissions and how much we need to reduce them. First of all, understanding what are the hotspots, and then trying to prioritize, let's say, the action to reduce those hotspots, at least in the macro area. Of course, this requires a lot of improvement every year, and continuous improvements, and improvements also in terms of knowledge, capability, capacity building, and so on. So I hope I didn't confuse you too much with this, let's say, work. So we have progressed a lot in 1 year. The real hard work is going still to come, but we're working on that. So I'm happy to answer any question if this is the case.
Thank you, Elisabetta. This is again reinforcing that these problems are very complex, and we are all trying to approach them from multiple angles. This is obviously easier for some people than for some smaller collaborations than it is for bigger ones, which is good. It's good that we're having this conversation. Kevin, do you want to go ahead?
Sure. But first of all, first success was just getting to a baseline inventory for 2019, which was about 2,000 tons for the Keck Observatory. 80% of that was electricity. Next one, 14% aviation component of business travel, and the remaining 6% was direct emissions, or scope 1. But when we understood that electricity represented 80%, and by the way, that's what I'm hearing from other observatories, data emerging on Mauna Kea. Went back and looked at a deep dive on what the consumption trend has been. because we have been focusing on trying to reduce our electricity usage. So looking at the consumption trend in terms of megawatt hours per year and what the carbon intensity is of the electricity grid that's supplying electricity. So I went back to 2005 and I actually found that Keck electricity purchases peaked in 2006. And that's when we deployed our first laser guide star. And that's when it became fully operational. Since then, despite adding new capability, new instruments, more powerful lasers, we've seen a steady decline from 2006 to 2019 to 25% below that peak. And that's through multiple efficiency upgrades, motor upgrades, replacing the liquidized lasers with more efficient, more powerful solid state lasers, lighting upgrades, virtualization of a significant portion of our computing infrastructure, which yielded significant savings, and then multiple solar PV installations. And then from 2019 to 2021, it dropped further to just 37% below our peak. And that was mostly due to PV installation at the summit. It took significant effort to get some insights on what the actual carbon intensity is for our local island grid. It was quite a challenge. Eventually, we did get it for some selected years, and we have a commitment to get it going forward. But between 2019 and 2021, the combination of what we were doing in terms of consumption of electricity and the greener grid, in just 2 years, our scope 2 greenhouse gas decreased by 33%. In fact, almost exactly 33%. It was a little over 1,500 tons to just over 1,000 tons. So it still represents the largest contributor to our carbon footprint. So there's a lot of work to go, but I think that's probably one of our biggest achievements, over the last decade or so.
That's really impressive, and it brings up the point that decarbonizing and optimizing the existing infrastructures together with having new things put in place, new measures put in place is really, really important. Elena, do you want to go next?
Yes, thank you. So as I said before, so in the first part, I think formalizing sustainability as a core value for ESO, I think this is one of the biggest thing we have done and puts us on the right track. On the other hand, on sustainability, on environmental sustainability, we also saw in our CO2 footprint assessment that energy was, I think it was with 40%, one of the biggest chunks. So we are moving to a greener energy. This is with photovoltaic plants in Paranal and La Silla. We have geothermal energy on in the headquarters in Garching, and in Vitacura we are undergoing now a project to make the energy supply also greener. We have also other initiatives because sustainability, we see it also on the social pillar and the financial pillar. So on the social pillar, one of the initiatives, which I think is very important, we made it's called Second Chance Program, is for a vulnerable woman in Antofagasta. This is the closest town to Paranal, where we offered training for coating of mirrors, and this was a success. And we are trying to see how we can improve or make a positive impact with our infrastructures to the local communities there. And the thing that will, I think will have a huge impact is we are working right now on developing a sustainable procurement policy and including in our evaluation criteria, sustainable criteria. What CO2 footprint does this thing we buy have? Does the company providing the service have diversity and inclusion principles? Do they operate like that? So this is a big thing, and I think this will change a lot.
Thank you, Elena. Indeed, this procurement policy, I think, is kind of leading the way. I think ESO is potentially the first organization to think about this, and you're also having this incredible approach of working with the local communities and creating energy grids that work service, not just your telescopes, but also the local area, which is really good. Brian, do you want to go next?
Sure. I think the progress we've made is kind of starting early and trying to figure out how to do these projects. We have the PV installations in Hawaii and Chile, which are now generating about 10 to 20% of our energy needs. And we've done some of the other efficiency improvements, so we kind of know how to do it. Have a lot of really energetic, engineering staff to help out, and now we can apply it to the rest of the lab.
Thank you, Brian. That's also really, really good. It's some very good points there. Violette, do you want to add anything as well?
Do you call my name? Sorry, I was coughing.
You had your hand raised.
Yeah, I did, but I was coughing when you mentioned my name.
Oh, sorry.
Bad timing. So yes, well, I just want to add, those are all great ideas. So I don't want to sort of move in a different directions. I think these are all things that all our institutions need to do in our organizations to think about. I like what Elena said about formalizing sustainability being very important. With some notes here, move to greener energy, individual telescopes need to do that. I remember dreaming of solar energy when I was working at ALMA some years ago. It'll hopefully be reality, fly less, etc., and make sure, we think about resources. But I'd like to take a different direction as well, because this is not something we think about maybe as much as we think about how to lower our own footprint, which is a must, it's the first step, of course. At the same time, astronomy gets a lot of publicity. Telescopes like the EHT get a lot of publicity and make great images. The public is a fan of what we do. And I think it is also a responsibility to not only lower our own emission, but also to be a voice for that, both within our organizations, goes back to formalize sustainability internally, to our funding agencies, make sure that it becomes a priority from the top, and to the public. While people are more aware of climate concerns and certainly are more anxious and worried, like we are, politics is not always moving in the same direction as fast as it should. And some bigger decisions need to come from outside of our own community, need to come from the top, and putting pressure, on the population. So one thing we have done here at Leiden Observatory is to start outreach events which are aimed at astronomy and climate specifically. We're aiming schools, for example. We just had a prize this last year about this. Creating a network within the A4E and similar organizations. We need to talk about it to the public, and we need to make sure that funding agencies are also on board. I went to this event yesterday. We had prizes we got a prize for outreach again, which is great. But one of for me, it was actually really tough to be there because one of the sponsors was a fossil fuel company. And it was really distressful for me to see how this is endorsed by our community and by scientists. And I think that shouldn't be endorsed anymore. So that has to be part of what we do as well as communication. I think I'll close there.
Thank you, Violette. This is a very important point, and indeed it's one of the reasons why A4E exists. We are also communicators, teachers, and many of us are, and we have a voice outside of just astronomy in our collaboration. So getting these things out there is very important. This actually leads to the next question quite smoothly, so thank you for that. So question 3 was, all our organizations either encompass international partners or cater to an international community. How do you get everyone to discuss and to agree on these sustainability goals? Something that we've also had some questions about this in the chat, and something that has been brought up by several of you in your introductions. How do we get the politics out of the way, and how do we converge on solutions?
Yes, I wanted to just follow up on this, because I think one question from the chat from Etienne, I think really fits nicely to this. That one was to Kevin, and it said, are astronomers in Hawaii communicating with local groups organizing to minimize the devastating ecological impact of, for example, Navy and Army pollution. So I don't know if, yeah, it's not necessarily close partners, or I don't know, but maybe that fits into here as well.
Okay, do you want to get started?
Yes, let's do that. Thank you. I think one aspect is just giving it visibility continuously, making sustainability part of everything that you do. At some point, people get convinced that's important. Also, there's people who are a bit slower, but that's quite okay. If we give it visibility, then that's I think a first step. The other thing is that I think that sustainability is also fun. You know, if you want to design for low energy consumption or low carbon footprint, that's a challenge by itself, which I think is completely fun to see how far can we get. And if you communicate the fun out of this to people, it makes people enthusiastic.
Thank you. That's a very good point. Always having it as part of the conversation and making it sound not just dire, but also focusing on the promising and challenging side of it. I think that's a very good point. Brian?
I can address some of the international nature of it. Yeah, trying to do is just get the oversight committees involved, like the Gemini board, so they understand what we're doing and get buy-in from the top level. It helps that, you know, the various efforts are not impacting operations, and, you know, in general, for the international partners, it's not costing them any more. And if anything, in the long run, it will save money, which helps.
Absolutely. I think appealing to people's pockets is also a good strategy. That always seems to work with governments, if nothing else. Anyone else that wants to address this question? The question that Sarah asked, maybe we can incorporate that into a question. We do have a question on working with local organizations and the local communities. So maybe we can just address that as part of that. So the next question we have is, does your organization have a plan to reach net zero? If so, by when? I think you've all more or less addressed these in your presentation. So to what degree this is controlled internally, for example, decarbonizing existing infrastructure versus relying on external changes like running on renewable energy, which might not depend on you. Again, I think a lot of you have addressed these as part of your presentations or the earlier discussion. Do you have anything else you want to add, any of you? Kevin?
Sure. So we have done a full greenhouse gas inventory for scope 1 and 2 and a partial one for scope 3. We have a strategy for net zero for scope 1 and 2. Observatory leadership, with the support of our governance board, has set the goal of achieving net zero for scope 1 and 2 by 2035, and our leadership and our staff are actually aspiring to reach that by 2030. And a actually press release went out Monday of last week announcing that. And to what extent is that internal versus external? It's a bit of both. Over 99% of our scope 1 emissions are from our vehicle fleet. And we've already purchased our first EV and installed our first charging station. We have plans to scale up in 2023. We realistically expect to complete the fleet conversion by 2030. I know we got to work with other observatories on the island in terms of charging infrastructure from different locations. And that's something of a challenge here on Hawaii Island. For scope 2, so for scope 1 is really, it's mostly internal. For scope 2, it's both internal and external. The state of Hawaii has legislated economy-wide net zero by 2045. And that includes for all the electric utilities. And Hawaii Electric has announced even more ambitious 2030 expectations for the Hawaii Island grid. So already last year, it was the greenest grid in the island chain. And there's a lot happening over the next couple of years too. I think by the end of next year, we could easily be over 75% renewable, which is great. And we also have active plans to continue our internal efficiency improvements. We've identified dozens, and we've teed up four for this current fiscal year. So, I mean, that's where we're at in terms of climate action. I wouldn't, until we've done a full inventory and we've worked out a full timetable, I wouldn't call it a full, full action plan. But we have a strategy and we're working on it.
Thank you, Kevin. That's really reassuring, and the fact that you're liaising with the local government as well is very promising. That you can have these conversations and have a joint approach. Brian?
I'd say full net zero for us, for NORLAB, is probably a stretch goal. As I mentioned, the original goal was a 30% reduction. With the additional funding for the Pachón PV, we want to get the Pachón operations, at least the Gemini South, to net zero, be like overall about 50%. And then we'll be studying further reductions, like with Rubin operations and for other sites.
Thank you, Brian. That's also a very important point, that sometimes complete net zero might not be possible if you want to keep operations. We'll have some discussion on this later as well, where to balance things and what the goals should be for each particular case. Anyone else? If not, maybe we can go on to the next question, which is something that I think, again, a lot of people who are not affected by this may not know about. So how is climate change already affecting your organization's facilities and infrastructures? So, for example, we had this massive recent wildfire at Peak. One of the LOFAR stations last summer got flooded as part of the massive floods in Germany and Central Europe. I think a lot of people are outside of the community are not aware that this is already affecting us directly. They think we are remote and we don't care about things. So how is this affecting your organizations already?
Maybe again here, one question from the chat could also be picked up. This one was from Volker, and for Elisabetta. How does ESA plan to deal with its direct impacts on the ozone layer? Maybe, yeah, that fits here.
We can start with Brian, maybe, while Elisabetta thinks about that.
Okay, I think you already mentioned the main impact on NORLAB, the Contreras fire. Basically, it's drought. The droughts in Arizona and Chile has been in drought for the last several years as well.
Yeah, it's been devastating for the local communities, as well as obviously very dangerous for infrastructures. Mm-hmm. Kevin? Mm-hmm.
Yeah, it's a good question to ask about Hawaii, because we're actually at risk for the full spectrum of natural disasters. Earthquakes. I just felt one an hour ago. Volcanic eruptions. We had a second volcano go off yesterday. I could actually see lava flow from my house. Luckily, it's 50 miles away. Tsunamis, floods, wildfires, hurricanes, all of those have touched our communities since 2005. But the only ones that could potentially be linked to climate change are the last three. It was really floods, wildfire, and hurricanes. Our facilities are at very low risk for wildfire, but it has impacted our staff. We have a low risk for flooding, and it's just at our headquarters. We're at higher risk for hurricanes, but I'd say that at this point, there's insufficient evidence to suggest that climate change has increased the risk of hurricanes on Hawaii Island. So in a nutshell, we haven't seen much in terms of our facilities. So that's kind of self-lucky at this point.
Maybe I can go next. Let me stress Europe. It's maybe smaller in terms of land extension with respect to other areas all over the world, but those areas are very different, let's say, peculiarities in Italy, for example, land characterization and also science is very different from the one that we could have in the Netherlands, which is actually under the sea level. Or so the type of, let's say, exposure to vulnerability and to the level of fragility is different. We had actually in Italy floods these few days ago in some specific areas. We had real problems due to the ice melting, for example, and so we didn't have real problems in the Netherlands. I'm working from ESTEC, from Noordwijk, the technical, let's say, center of the European Space Agency. But still, with our mission, space mission objectives, we're trying to covering all those, let's say, possible scenarios in terms of global monitoring and environmental security, like, for example, with the Copernicus missions from the Earth observation. So, and this is one of our, let's say, challenges, if you remember the slide I showed before. So maximizing the return from space missions in terms of monitoring, observing, and preventing. Like, for example, we have a mission that will be launched very soon in 2025. It's named CO2 mission. So it will be flying with 3 different identical satellites, and is funded by the European Commission. So on that, we could monitor, let's say, the anthropogenic CO2 emissions. On top of that, there are many others, part, for example, of the Earth Explorer or Copernicus, in order to understand better what's going on. In the meanwhile, and on top, of course, we need to act from what we have on land. Let's say, let's start to emit much less than what we are doing. And this is what we are doing, let's say, pragmatically speaking, in the very short term under our, for our infrastructure. And as one of the other, let's say, speakers mentioned earlier, it's not surprisingly that we have the biggest contributors in terms of emissions are energy consumption and business travel. I mean, this is undeniable. So we are really working hard on that, and of course, too many other contributors to that. I'm really sorry, I need to leave you for today. I already communicated to you, but I will be super happy to answer your question or just exchange. I will leave you my email address from work. So glad to be here today. Thank you.
Thank you, Elisabetta. I know you have very tight constraints on your time, so thank you for joining us. We'll pass any questions on to you.
Bye.
So Elisabetta did bring a very important point, which is that we also have facilities to monitor climate change and to monitor the impact of our activities. And in fact, LOFAR monitors the ionosphere very closely. So Gert, maybe this leads on to whatever you want to contribute.
Well, yeah, sure, I can do that. You mentioned already the damage that was done to the German station, which is quite unfortunate as a result of flooding. We also had a storm affecting the Chibolton station a few years ago. Well, okay, we have storms more often, but whether that is climate change, you can debate. In the Netherlands, you see effects of LOFAR in the sense that in summer, we have to stop observing because the temperature of the electronics gets simply too high to do that. And we only have air cooling there. You also see that due to high nitrogen deposition and the climate change, that the maintenance that we have to do on the sites gets more intensive. But yes, these are all, I think, climate-related effects, but they're still manageable and unfortunate, but we can cope with it. Yeah, we use LOFAR for ionospheric monitoring. Interesting enough is that where the lower layers of the atmosphere warm up, the effect is that the ionosphere itself cools down. There is a coupling between them, which is already scientifically very interesting, but from a point of climate change, I don't think that the ionosphere matters that much, but it's scientifically very interesting, yes.
Thank you. I just wanted to bring up the point. I also find it very interesting, and I think, you know, for monitoring climate globally and monitoring the ionosphere globally, I think LOFAR is important. Brian?
Yes, to mention, yeah, we should, looking into the future, we need to continue monitoring long-term climate impacts on things like image quality and cloud cover. We haven't noticed anything obvious yet, but we need to keep that in mind. That may affect, you know, siting of future facilities or use of existing ones.
Thank you. Yeah, I think that's an important point. And also it's worth remembering that us as astronomers are still people. We still live in communities. And even if our favorite telescope is not affected, the people working there might be. So on to the next question, I think is kind of related. So sustainability, development, inclusion often go hand in hand. Does your work with local communities, for example, where facilities are built, cover these aspects together or separately? How and why? I think this also touches on some of the questions that have been asked on the chat. Any takers on these? Elena?
So ESO has increasingly been working in the last 2 decades to improve the relation with the local communities and to increase the positive impact. What if it would be good to have an observatory close to your community? So we are trying to focus on joint discussions and on creating projects where we have a win-win relation. As the Second Chance program I was explaining. And at the moment, we are looking at renewing the agreements with the local universities to make it, what can we really offer and what can they really offer, and make it sustainable in that direction.
Thank you, Elena. That's really promising. And we did address this as well earlier with, working with local governments, working with local communities. Does anybody else want to have anything you want to add?
Maybe a completely different topic, but LOFAR is in the public space in the Netherlands, and in the same areas because it's being remote, where people want to put solar panels and windmills. And it takes us a lot of effort to communicate with the communities around LOFAR to make sure that they are well informed about our needs, and also that we supply them with the right information so that they can put their plans into place with respect to whatever they want to do in renewables. And that's very important that we keep that in mind, that despite the fact that we want the windmills as far back as possible and solar panels being not generating any EMC, we have to live together there, and that simply requires a lot of attention.
Thank you. That's a very, very important point, and in fact maybe ties up to some of the earlier discussion about the impact of stuff in space. There are some plans to add sustainable things in space, like solar panels and stuff, and how that will affect astronomy is a whole matter of a complex debate. John?
Yeah, I just wanted to say that negotiations with the indigenous peoples who own the lands that we're building our new telescope on, the SKA, and that we have built the telescope, a new ASCAP telescope on. Those negotiations are critical. The land that we're using is owned by the traditional owners, so native title exists on those lands, and so we enter into what's called an Indigenous Land Use Agreement, and that certainly covers heritage protection, ecological protection, and environmental factors as well. So from those perspectives, it's all quite rigorous and done in a sustainable way. It doesn't, however, cover carbon emissions directly, so that driving force is coming more from our own internal CSIRO goals to reach net zero by 2030.
Thank you, John. That's a very important point. Thank you for bringing it up. Indeed, the SKA has made this agreement with local communities, this respectful engagement with local communities, part of the central core part of the design and the operations, which I think is really promising, and again, something forward-looking. Kevin?
Yeah, to be honest with you, it's a little bit outside my lane, but I've just got an email from one of my colleagues, and I'll just read you from that. And that's, the state of Hawaii has recently passed a law, the creation of Mauna Kea Stewardship and Oversight Authority. And that's a decision-making body. It's comprised of a representative from the local community, including the native Hawaiian community, and they will be tasked with the management of Mauna Kea, and that encompasses issues related to the health and well-being of the mountain, from cultural to environmental to astronomy use and more. And one of our own staff, Rich Matsuda, he's been appointed to the Mauna Kea Stewardship and Oversight Authority as the Mauna Kea Observatory representative. So this is a new authority, and we anticipate that sustainability, development, including land use and inclusion, will be addressed as part of that. So I just want to share that with you. It's not really, I'm a little outside my lane, but that's what we're doing in that, and we have some key leadership involved in that too.
Thank you, Kevin. That's really good to know. I know that a lot of eyes have been on Mauna Kea in recent years because of these discussions. So I'm glad that there is now some plan and that things are moving forward, hopefully in a way that everybody will be happy with. So maybe we can move on to the next question. Is there, unless you wanted to add anything more, John, since your hand is raised? Oh no. Okay. Thank you. So it's okay. Did you want to add something else?
No, it's fine. Sorry, I just forgot to lower my hand.
Is there a formal publicly available evaluation done before construction to find out the impact on indigenous communities and biodiversity of the land used for astronomy or space facilities? Permission from local environmental authorities might not be enough because of challenging political scenarios. I think, to be honest, this follows up, and we have had most of this discussion as part of the previous question. So unless there's anything else, any of you want to add? Brian?
I think in Chile, there will have to be studies for petroglyphs, endangered plants before construction of any additional PV, and likely the same thing in Arizona and other places.
That's a good point. You have to work with other local resources as well, and be careful and respectful of other resources, even when chasing up sustainability goals. Thank you. So the next question we had is probably more for Patrick, now that Elisabetta isn't here. Can we make space-based astronomy sustainable, or should we be looking to offset its impact with reductions elsewhere? And we've had a couple of questions in the chat related to space tourism and space exploration in general. I know this is a very complex and very polemic topic in some ways. I don't know if you have any input on this, Pat?
Well, I would say that, the Federal Communications Commission in the United States just recently passed a rule saying you have to dispose of your spacecraft after 5 years at end of mission. And that usually means burning them up in the atmosphere. If you have 100 to 300,000 satellites with a 10-year lifetime, then you're talking about tens of thousands of satellites going up every year and tens of thousands of satellites coming down. The launches leave a major environmental impact. I'm not competent to speak more on that. Certainly, things burning up in the atmosphere will leave particulates in the atmosphere, alumina and things. And it's a very difficult problem, and I don't know what the solution is. I think space tourism at this point is a pretty minor role there, but it needs to be looked into. And launching constellations of space telescopes, as some of my colleagues are now talking about, only adds to that issue there. So I can only talk in generalities here and not in specifics, but every single launch has an environmental impact, particularly when you look at the full life cycle: launch, the recovery or burn up of the rocket body in the atmosphere, and then what happens at the end of mission. The environmental impact can be quite severe.
Yeah, Elisabetta is not here, but ESA has also been doing like full cycle assessments of space missions and stuff like that. So there's definitely a lot of work going on these on the astronomy side of things. But you bring up some important points that we need to have these conversations with government and with industry as well to make sure that everybody has a say in this. The sky doesn't belong to a few corporations, really. The sky belongs to everyone, and it's a very complex topic. So leading on to the next question, really, it's unrelated. How will pollution from existing and planned satellites impact current and future ground observatories, and what can we do to prevent or mitigate this? Do you want to carry on, Pat, since you're here?
Well, I think that the issue is to try to put them at as low Earth orbit. I mean, the recommendations of the astronomers that came out of SATCON 1, the Satellite Constellation 1 workshop, was to make them fainter than 7th magnitude, visual magnitude, so they are not detectable by the human eye, and it avoids the most serious problems in Rubin Observatory, which is the wide field telescope nearing completion in Chile now, and which will do the entire southern sky every couple of nights. I mean, it basically eats the night sky alive. And the issue there is, again, both the 7th magnitude limit is so you don't see it with the eye, and it avoids the most serious nonlinearity effects in the Rubin detectors. But we're seeing very large or even small constellations of satellites like Blue Walker 3, which are 2nd magnitude. And so you can see them from even light polluted sites. And I just, you know, it would be great if everybody could keep the 7th magnitude limit, but I don't see it happening. And I really don't know. I'm despairing at this point. And there are many second order issues on these large constellations, and that is the space debris issue, the generation of what you might call pollution of very small particles as these large satellites collide, and they will collide. You have to now, I think the next thing the FCC is going to have to impose is that satellites have to be maneuverable above 400 kilometers to avoid conjunctions, to avoid collisions. And that has not really been thought out. It was very much opposed by the industry when it was proposed a couple of years ago. But now your satellites get larger. They will have be emitting pollutants as they maneuver. And so there's a whole number of issues here that are just being worked through at the present time. And it all goes back to the phrase that I used earlier, the long-term sustainability of space, and how you know, how can space be made sustainable over the period of centuries, you know, not just a few years. So that's all I can say at the moment.
Thank you, Pat. These are all super important points, and I'm really glad that you brought them up. And again, conversations that we need to carry on having with a lot of people to ensure that we move things forward as a community. And also reminding some people that just because you cannot see something with an optical telescope, it doesn't mean that you cannot see it at other wavelengths.
Yeah, exactly. And in the thermal infrared, these objects glow in the dark. And so that's another issue there. You know, I was reading the chat side here, and somebody said, well, you know, the contribution of traveling astronomers is pretty small to the global airline industry. I think the point is everyone is going to have to sacrifice. Everyone is going to have to change how they work. And just because you say, well, I don't contribute very much and therefore I don't have to worry about it. For example, one of the constellation builders of this Blue Walker 3 are saying, well, we have a small number of satellites. Okay, so we're not going to affect astronomy very much because we're just going to launch 180 into low Earth orbit, and therefore there'll just be a few visible at any one time. If everyone took that attitude, then the night sky is lost. And so everyone is going to have to change their behavior.
Thank you. That's, again, a really, really important point. Brian?
Yeah, just like to second Pat's comments, you summarized the problem really well. So NORLAB is running these giant imagers which are being impacted by the satellite constellations. So yeah, we're trying to work with international organizations and the satellite manufacturers with SpaceX and so on to try to mitigate the problems on both hardware and data reduction sides. I'm going to put in the chat here a link to the NORLAB webpage, which can go more into efforts on that.
Thank you. That's really good. That's a very, very good point. Gert?
Thank you. Yeah, I want to applaud to Patrick Seitzer's remark from a couple of minutes ago. We are all responsible for what we do, and there is no point in pointing to somebody else who has a higher number or a lower number or whatsoever. We have to make our own contribution, what we think is important. If you saw, for instance, the presentation that I gave at the beginning, there is a number on how much carbon emission we have from a normal LOFAR observation. It's not intended to compare, okay, are we doing better than somebody else? No, it's just to inform us what we have to do without any comparison to whoever.
Indeed, again, very good points. This is all our collective responsibility. We cannot just pass this on to somebody else, even if we feel we don't have the decision power to push things through. We still are responsible for our own emissions and for what we do with the data we have, with everything, you know, as we live, and we still have a voice that can be heard. Violette?
Yes, there's a discussion ongoing about this in the chat as well. I just wanted to voice it a little bit here. Because again, I agree that, and I really agree that we must do all we can to decarbonize ourselves. But I don't fully agree with the description that this is our responsibility. This is the responsibility of our politicians. So we can also point in that direction, and we should. They have much more power than we have. In reality, they do. Because even honestly, somebody made this point in the chat. We are not the end point of this. There's a big, you know, population that also consumes, and not all of them are going to be getting aligned and have the discipline. We cannot expect this from individuals. So politicians are responsible, and it's our responsibility as educated parts of the world, the community, to push in that direction as well.
Indeed, again, very important points, and we have some A4E projects dealing precisely with this and what we can do as a community to make change happen, you know, in the top layers of government as well. So maybe this is a good point to bring in more questions from the chat. We have had a very active discussion. There are some really good points raised.
Yes, there is one other question which I think fits in here very well in this situation, because it's also not very not feasible for any individual, but I think this is something that does lay in our power. The question was by Nicholas Flagey, and it was, how can we reduce the overall footprint of astronomy, for example, by doing all these great things we are talking about today, if the culture in astronomy keeps pushing for more and more and more, for example, in publications, in meetings, and data. So yeah, anyone who would like to address, maybe raise your hand to comment on this.
I would again jump in just very briefly. We have an A4E project dealing with this. So if you watch the videos for the A4E projects, and we're going to have a discussion on that as well tomorrow. So anyone else here who wants to join, you're all very welcome to contribute ideas to that. Is something we will really want to tackle as a community. Anyone have some input on this? How can we change the culture?
I don't know. I was going to ask this question to you, Violette, at the end, because she was, so you're surprised. So that cultures have a different understanding of sustainability. So my view, but it's only my view, is not that there is a different understanding. So the importance and awareness is there, but the problem is when it gets to money. So if it has a cost impact, then we do have a problem. Otherwise, they tend to agree. I don't know how you can change a culture if it's not by raising awareness through all the measures, and institutions like ours who have a certain power. ESO does have big contracts and so on, making sustainability as a principle, and just operate with partners who also agree on those principles, social and environmental sustainability.
Yes, thank you very much. Kevin, also.
Yeah, I'll I guess the chat question was in the context of, you know, the desire to do more and more, and I'll just add a comment that, you know, well, how do you do more and more but with less or the same? And, you know, in terms of the ground-based astronomy, you know, to take full advantage of what's already in the archives. And that's something that CAC has invested heavily in over the last few years, is ramping up the speed and the quality of what's been put into the archives instead of in terms of data reduced science products. And it may be, you know, that's at least some of what you need to answer your science questions is already out there lurking. And so that's certainly one option to do more with the same or less.
That's a very good point. And indeed, I mean, we've had discussions about how the career structure, for example, favors people who propose new things, building new stuff, getting new data sets, and we are not fully exploiting what is already there. There's something we need to change the mentality a little bit, and maybe start including carbon costs into projects. But making these data available in a way that the community can use them is the starting point. Otherwise, there's you know, we're not going to change things if the data are not out there. And I think from my radio bias perspective, this is something that wasn't very good in the past, but I think the radio community in particular, which has been inaccessible for a lot of people and very obscure in some ways, has really been pushing forward.
And I'll just add there, we have noticed a distinct uptick in the number of science papers that are resulting from data that's in the Keck Observatory archive. So that's a positive sign.
Yeah. And it's probably making things accessible to communities who would not be able to apply for time otherwise.
Yeah, yeah.
Violet?
Yeah. So yeah, I also like this topic of, by the way, I was gonna get back to it, Elena, but topic of cultural change and cultural shift that has to go with it, and not think about always growth, but also sort of sustainable growth and using more archives, and maybe have different ways of assessing, you know, the work that we do. But going back to the question of Elena regarding what are the you know, cultural changes that go into this discussion, how they can affect it. I think ESO is in a great position right now. I really applaud the work and the support of the DG, and that's regarding sustainable. I've said this many times, and you know, it's really a great example, and I think it will actually have an impact on has an impact already on other agencies and observatories. That being said, not all observatories are already on board with this, even large ones. Maybe some of the emerging ones are already looking into this for the ones that are being built, which is great, SK, etc. But not all of them have that or think it's important. And in some countries, and I won't, you know, go into it, but it's considered not a climate issue, not a scientific issue, but a political issue. And I've had pushback on this. Personally, I have, where I've raised climate concerns for our observatory, and people say, well, this is a political discussion, we won't have that here. And this happens, and a lot of people think that way still. And we think everybody's on board, but they're not. Even our colleagues, because unfortunately it has become politicized on purpose by some companies, and culturally has that way. Some other countries, and this is again a problem with different cultures, have other concerns, they have more urgent issues and more things they need to invest and cannot always invest in green energy. So these differences exist, and I've faced them. I've faced different discussions where people are not on the same page. Now we all are by definition, because we're all here, but that's not true for the whole community. And so I think talking about it is important. A movement like A4E is extremely important, because more and more people join, and it's normalizing the topic, I think, for astronomers. But it's still an issue. Different cultures have very different views on this.
Yes, and in fact, this is something that has been picked up at the recent COP, you know, the global balance, and why, you know, developed, quote unquote, countries are now entitled to tell other countries, no, sorry, you cannot develop at this pace because your carbon emissions, blah, blah, when they have been, you know, the culprits in the first place. It's a very complex discussion. It's something we definitely need to discuss together. And politically, it's very complicated even within the same country. It's why I was so happy to see Brian's presentation, for example, and seeing what NOAA Lab has been doing, again, on a multifaceted approach. In a way, you can start make changes and then tell the politicians late in some facets, and you can start make changes even with a current structure while trying to push the conversation forward, I think. Gert?
Thank you, Beatrice. Cultural change is something very difficult, especially if it relates to a global community. It's much harder. I'm not an astronomer myself. I'm just a physicist and degraded to management roles, etc. So I have easy talking here. But I have a question, and that is that, in my opinion, the cultural change is extremely hard for young scientists stepping into their careers, making their first steps, if the senior astronomers who have arrived do not change. They have to accommodate to a world that is functioning in a certain way, and they cannot change in their early career steps the cultural change that is required. So my question is, isn't there a huge special responsibility for those who have arrived in their careers to change the culture for the young people who still have to do their careers?
Thank you. This is a super important point. And again, we want to avoid generational strife as much as we can, because things are already polarized very badly, and not, dividing the community even further is a problem. But yes, there needs to be some massive structural change. And unfortunately, I include myself in this, even though I'm experienced, I still don't have a permanent position. Many people here, the demographics of this meeting are skewed towards the younger generation. We cannot do this from the bottom up. We need help from the people who are already established to drive these changes. It's why it's so important that all of you are here and we are having these discussions, and that more people become aware that this is not just, a matter of, curtailing carbon emissions. It also needs to happen structurally at career level, at funding level, and so on and so forth. Thank you for bringing this up. Ryan?
I mentioned that I think the current and future emphasis on time domain astronomy and large surveys will help drive a lot of the paradigm shift. Things like Ziki Transit Facility, Sky Mapper, Atlas, Rubin. In a couple of years, the universe will live in the data center, not just in the sky. So that'll drive a lot and reduce maybe the need for a lot of travel to observatories. At the same time, observatories need to have either service, queue, remote observing options so that travel isn't needed. For example, when Gemini started, Q was still rather novel, and there was a big discussion about ratio of Q to classical or visitor mode. And people basically voted with Q in Gemini's case. It's not worth traveling halfway around the world for 2 nights when you get clouded out. You might as well have the Q take care of it. And in terms of travel, I think it may be important to give allow younger people to travel more. I mean, it's important for their careers, it's important for training. So we need to find the right balance.
Absolutely, balance is very important, and traveling is. There's a recent French study which is mentioned by several videos in this meeting that shows that the traveling to conferences is a huge problem for astronomy, more than traveling to observe. Based on the French perspective, obviously, it's a study that is based on the French community compared to other sciences. So this is again a discussion we need to have in terms of how we can curtail our travel and still be productive and still be competitive and still make sure that the community as a whole is more representative. So all of this is very important. I'm keeping an eye on the time. I don't want to keep people longer than the allocated time, especially for those of you who are there in the middle of the night. We did have a couple of rather important topics in the questions we had already asked, and I think they tie again with some of the stuff that's been asked in the chat. So I think maybe leaving traveling aside now, because there has been a lot of discussion on this and there will be more throughout the symposium. I did want to hear about the computing side of astronomy, which is particularly sensitive for people who are doing data intensive things like radio, but it's important to everyone. And again, this was mentioned earlier by John. Australia has a very high carbon footprint. There's been some discussion in the chat here, just because of the type of energy resources that are used to power these computers. So how can we do to minimize the impact of computing? What do you think we can do to improve the situation?
Would you like me to say a few words, Beatrice? I can kick it off. So Yeah, I mentioned the paper by Adam from 2 years ago, which identified high performance computing as our single biggest source of carbon in Australian astronomy. So I'm not sure if you've been following the chat, but the new computer that we have at the Pawsey Supercomputing Centre is certainly, it's hugely more efficient in gigaflops per watt, unusual unit, than the previous large computer. So that's a big step forward there. However, it's a bigger computer. So even though it's something like 30 times more powerful, and it's much more efficient, it still uses more energy than the old one. So this feeds into the discussion that's been happening in the chat too about continuous growth and whether such a thing as sustainable growth actually exists. So to offset that, a couple of points. One is there is some standalone photovoltaic generation associated with that new computer. I just had the number written down, 120 kilowatts, which probably isn't a very large fraction of the total power drain on it. There was an interesting article written by the director of Pawsey, which showed up in the Australian on an Australian website called The Conversation, which folks might like to find. Mark points out that supercomputing probably has a very important role in a sustainable energy going forward in the modelling that it can do into such things as wave energy, hydrogen cells. He lists a few different things there. So there is an offset in that all sort of strategic sense. And the other point I'd make is that I totally endorse, I think it was Kevin's comments about utilising archives to the max. But to some extent, I guess that does entail having data centres and high performance computers where all these lovely archives can be kept and cross-matched to extract the most information from them. So yeah, a mixture of positive and positive developments and things that probably need more attention.
Thank you. Those are some really, really important points. Does anybody else have anything to add here? I'm also keeping in mind things like there's been a recent study, there's been a few recent studies showing that Python is like the worst programming language you can use in terms of carbon footprint. Obviously, we don't all want to go down to assembly level, but there have to be ways to optimize our code and optimize what we do with these computers as well. Does anybody have anything to add here, Kevin?
Just make a couple of side addresses at the scale that the supercomputing level. But one thing we did back in, I think it was like 2014 or so, is we actually replaced a lot of our independent servers with scalable virtual computing racks. And I tell you, I mean, it was dramatic. There was a computer room that had stacks of servers. We replaced it with virtualized stack, and the air conditioning could now handle the load without maxing out. And I actually saw it in the utility bills a month later. And it also added a resilience, redundancy, more easily to scale, and actually a lot of scope 3 issues with regard to buying and disposing of equipment. And the other thing is we've been moving more and more services to the cloud. And an important consideration, moving it to the cloud, it removes it from your scope 1 and maybe scope 3, but it adds. You got to figure out, well, how green is the cloud? So you really have to dig deep and look at what Microsoft and Google and AWS. They all have climate action plans at different levels of maturity. So you really have to look in there and see where the opportunities are.
Thank you again. Very, very important points. Anything else to add on this? Again, we're keeping an eye on the time as well. We don't want to keep you too long. Anything else on the computing side of things? Again, this is all meant to start some conversations, so please keep these going, and we will keep discussing things on Slack as well, and collect all of these questions together and tackle them separately and send them to people. If not, then perhaps, I mean, there's another point which we have discussed already briefly, which is the potential to slow things down, maybe. Do we need to make compromises? Do we need to prioritize carbon footprint reductions in favor of, instead of delivering everything that has been promised for current or future observatories? Is there a balance to be reached there? What do you think is the right approach here, or do we need to start having these discussions? And there was some related questions in the chat on these as well. Don't know if Sarah links to it. So SKA has lots of plans for PV power, but it's still using diesel for backup or night power. Should we instead use less and switch off the telescopes when renewable power is not available? So again, all of these discussions are difficult. Do we need to start having them? Can we carry on as usual? Can we start making compromises here? What do you think is the right approach? Politically complicated questions, sorry.
Oh, I might just chip in. The problem of only observing during the day in radio astronomy may sound great, but it's probably not practical. There are good reasons for observing at night, even for radio astronomy. But I think battery storage must be part of the solution here. So for our ASCAP telescope, we're currently about 45 to 50% renewable with our hybrid power plant. Our CSIRO board has told us we have to be 100% renewable by 2025. And the simplest way to do that is to invest in battery storage. And I'm certain that SK will be looking at that as well.
Yes, can I go there, please? Yeah, okay. My perspective on this is we have to look at two aspects here. It's not only the sustainable energy, but also the amount of energy that we use, because you can use an enormous amount of green energy, but it's still energy that you use. So the fact that it's green is not making it okay. Personally, I could imagine that where a lot of facilities have proposal cycles and proposal committees in which there are boundary conditions to the outcome of a proposal process, which relate to, for instance, the time on sky that's available, or the number of flops that you have, or the number of petabytes, or the number of FTEs in support staff, that you would add a fifth or sixth boundary condition relating to sustainability or energy consumption, to say, hey, here is my ceiling. If this ceiling is reached, then that was the last proposal that we grant. So that you keep it at a facility level, and then you have it somewhere covered in priorities.
Thank you. That's a very good point. Starting to measure things, not just in available hours, but in available power. I think that is a very, very important step forward that we probably need to start discussing. Brian, did you have something you wanted to add as well?
I just wanted to, I guess, mention that the batteries are going to be important, especially for nighttime operations. We need to collect the energy during the day and release it at night. So that's part of our plan as well.
Yeah, I think this is something that we can sell as well. The fact that there is a lot of potential synergy with industry to make things better, to try and minimize what is already there, and without sacrificing some of our goals and some of the investment that's already been put in sometimes. And I think maybe the EHD collaboration is a good example of these, recycling telescopes and all of the transient astronomy community that has appeared in the past few years, reutilizing smaller telescopes and infrastructures that are already in place. These are examples that we can use. We are actually leading the way in being, in recycling what we have. Any other takers on these, or anything else in the chat?
There would be one more question that maybe we could revisit. What are large consortia doing to move towards more equitable distribution of funded positions in favor of people from less privileged countries? It was a longer comment. Maybe you can go to it in the chat because we're running out of time. I just wanted to quickly give opportunity to comment on this. It is a big topic, so yeah, we probably can't open it up as much as it would deserve discussion today, but maybe any quick comments or thoughts on this before we maybe go to the final question?
Yeah, just while people think about this, it's been really reassuring in recent conferences as there has been a huge amount of emphasis put on inclusion and on bringing in people from underrepresented communities, from underrepresented countries, and keeping the expertise in those countries as well. I think this is a very important step forward, not just, poaching the talent and taking it to your country, but training these people, leaving them in place, developing the infrastructures there and developing the community there. So I think this is looking more hopeful than it was a few years ago. But yes, any input on this would be very welcome. Everybody's thinking hard. I mean, every large organization, I can say from the inside and the outside, has policies that now address this to at least to some extent. But yes, knowing the specifics would be good. Elena?
So at ESO, all the positions are open for, so they are not limited to the ESO member states. This is one of the things. But I believe, sorry, I just got lost in this thought. Yeah, so this, lost it, sorry.
So you were mentioning in the context of making sure that things are more equitable, that ESO has a policy that is open to anybody to be a member, not just...
And what I was going to say, thank you very much. And this is what we want to do when we renew the collaboration agreements with the local universities in Chile, for example, to promote that industry and that knowledge in the country. So to have really a win-win relationship.
Thank you, that's very good. And I think that all of these things that we have discussed in terms of work with local communities and promoting working together with the local community in developing infrastructure, making sure that this is sustainable both socially and ecologically, say, or on a global perspective is very important. So I think some of these changes will probably happen naturally as we find new ways of working and new ways of structuring things. But it's good that companies and the consortia and in these discussions that we are also involving industry, that we are moving forward as a community. Does anyone else have anything to add on this? If not, maybe we can start wrapping up. We did have one question to ask all of you panelists, and that is, what can we do as a community to make your job easier on the sustainability front? What can we do to help you and your organizations reach these net zero goals and to move these things forward? Kevin?
Yeah, I'd like to answer this question in the context of a broader impact, because if the Keck Observatory reaches its net zero goals, that would be great. That'd be awesome. But it's really only a drop in the ocean of need of what needs to be done. So it's a collective challenge. And it's going to take collective action to build momentum and make a real dent on what needs to be accomplished this decade. So the big opportunity I see is, how do we shorten the learning curve from climate awareness to action? And to my thinking, one way is by sharing lessons learned. By being as transparent as we can be about our carbon footprints, about strategies and plans to address them. We certainly learned a lot from the efforts at other observatories, and I have to say, hats off to Canada France Hawaii Telescope for being the first in actually doing a carbon footprint of the Mauna Kea observatories. If others can learn from what Keck is doing, that would be great. And I already mentioned earlier, the one thing that that we're specifically looking at in terms of challenge ahead is really, where's the sweet spot in terms of effort and outcomes in tackling scope 3.
Thank you. Again, very, very important points, and making sure that we do this, that we make these changes happen fast is really important. We cannot wait for funding bodies to discuss over the next decade and a half how to measure carbon footprint. We need to start implementing solutions now. Brian?
I agree. Also, it'd be useful to, talk to your funding agencies, the observatory users committees, anyone else, to emphasize that this is important, that we need to, the observatories and facilities need to be doing this, whether it's PV or efficiency gains or observing modes or whatever. Just make sure they know this is important.
Yeah, again, a very, very important point that this is something we can all do, and particularly anyone who is already established in the community, pushing up people who are doing this work, who can drive changes in terms of sustainability, and contrarily as well in terms of diversity, I think is very important. They go hand in hand, really. Elena?
Yeah, well, I think you all have a big role to play. So for ESO, you are all stakeholders in one way or the other. So you're kind of our counterpart. If we include the sustainability criteria, these have to be accepted and implemented. So it's kind of the ball we play against each other, and then it goes. It will be more important in the future. So I think so we were saying before, and I think it's really important to raise the awareness, to learn from each other. And the last point is I'm very, very thankful for the open discussion here. Thank you.
Thank you, Elena. And again, thank you all for being here and for participating in these. I know we've asked some tricky questions of all of you as well. Gert?
Yeah, I think there was a great discussion, and thank you for organizing this panel discussion and the entire conference. So I think that's a great contribution. What I would like to answer to your question is that I think that astronomy has something to offer to the world in terms of what we create as solutions is applicable elsewhere. So it's not only our problem, it's also something that if we have solved it, we can bring it to the other areas to apply as well. So we have something that is very valuable in terms of this transition.
That's an excellent point as well. And we have a track record of this, like, even just developing CCDs. Astronomy has been leading the way in many ways. So yeah. And also by leading this change, we make sure that people don't apply these changes to us in ways that we don't like. So I think this is all encouraging in terms of, we all need to push. Violette?
Yeah, so my final words, what can we do as a community first? I think A4E is doing a lot already and making this public and talking about it and forcing uncomfortable conversations in some places. It's great within our community. I just want to add, I think Brian already said something I wanted to say before regarding communication. So going back there again, talking about it also to our funding agencies and our colleagues. But finally, please remember outreach is important and very powerful tool to the public to communicate not only astronomy, but climate change. And I say it again, outreach is important for us in our communities. We need to use it and not only think about our consumption, but think about our inspiration to the people around us, to the communities around us.
Yes, again, a really, really important point. If nothing else, we can give people a sense of perspective that, the world is not just limited to us little humans in our little planet. We are all very aware that, things are larger in the universe, and transferring this knowledge and showing how we can change things as a community is very important, I think, in this aspect. Does anyone else have anything else you wanted to add? Again, while you think about this, I wanted to thank you all so much again for being here, for participating in this discussion, for saving your time, particularly those of you who are in the middle of the night. I'm sorry you had to sacrifice your sleep for this. I hope it was worth it. I hope you all got something out of this as well.
Thank you all. Thank you for organizing.
Thank you very much for the organization. Bye-bye.
Thank you, everyone. Take care, and let's carry on the conversation in Slack and in chats and everywhere.
Yes, thank you also from my
Bye.
side. And see you
Bye,
soon.
Sarah. Bye, Beatriz.
Thank you.
Thank you, everyone. Aloha.